In this lesson, let's take a look at momentum. Now, momentum is something that we all have an intuitive understanding of, but it's really defined mathematically. And momentum gets the symbol lowercase p. P is equal to mass times velocity. Now, I'm going to put little arrows above the p and the v to remind us that those are vectors and direction matters. So, momentum, which is sometimes called the quantity of motion, is a vector. It depends on which way it's going. So, if we had, say, two carts that are equal in mass, both say 2 kilogram cart there, and we'll have a 2 kilogram, well, maybe a 2 kilogram cart here, and let's say this one's going this way 3 meters per second, and this one's going this way 3 meters per second. Now, in my picture, I've got arrows, so I don't have to put direction, but I should establish both a positive and a negative direction. My positive direction, I'm going to say, is to the right, so this way is positive, which means to the left is negative. That means when I find the momentum of this cart, it's actually 2 times negative 3, which equals negative 6 kilogram meters per second. This cart has a momentum of 2 times positive 3, which is 6 kilogram meters per second. So they have equal momentums, but in opposite directions, so they have opposite momentums. So momentum is a vector, direction does matter. Now the other interesting thing about momentum is that thing where it depends on both mass and velocity means just knowing something's momentum doesn't allow us to know its mass or its velocity. So for instance, if we had another set of carts, say this one, and I'm going to tell you that its momentum is equal to 12 kilogram meters per second, and I've got another cart that also has a momentum of 12 kilogram meters per second. What I know for sure is those things are both moving in the same direction because they both have a positive momentum. They have the same to the right momentum. But I don't know if they're moving the same speed or if they're moving different speeds or if they have the same or different masses. So if I said this one has a mass of 3 kilograms, that would allow me to figure out its velocity. I could say, well, P equals mv, so 12 equals 3 times v, divide by 3, and I get a velocity of 4 meters per second. Okay? But if this thing has a mass of 6 kilograms, then its momentum, 12, is equal to its mass, 6, times its velocity, v, and its v is only 2 meters per second. So while both of those things have the same momentum, they don't have the same mass, they don't have the same speed. So what this one lacks in speed, it makes up for in mass, and what this one lacks in mass, it makes up for in speed. So any combination of mass and velocity that gets me to the same momentum means those carts have the same momentum. What does that mean? It means they'd both be equally hard to stop. Okay? There's one other way both of those carts could have the same momentum. They could both be at rest, because an object at rest has no momentum. Its velocity is 0, so its momentum is 0. Now, one more thing to look at here is the idea of a system of objects. A system of objects is a way to define what we're particularly interested in. So if we had railroad tracks, and we had a cart here, and another railroad car over here, and say this one was moving this way at 3 meters per second, and it has a mass of 1,000 kilograms, and this one, that's 1,000, and this one has a mass of 500 kilograms, and it's moving at 4 meters per second. What is the momentum of our system? Well, the momentum of our system is the momentum of both of these things added together. And since they're moving the same direction to the right, that's actually going to increase the momentum of the system compared to the momentum of an object. So I could take 4 times 500 plus 3 times 1,000, and what I see is 2,000 plus 3,000 equals 5,000 kilogram meters per second. Right? So the momentum of the system is the momentum of everything in the system added together. And I was paying attention to direction, because if there was another, we could increase this, and we could say, well, what if there's a third cart that's moving this way, and it looks like an 800 kilogram cart, and say it's moving at 5 meters per second. Well, then its momentum is 5, negative 5, because it's the other direction, times 800, which is negative 4,000 kilogram meters per second. And if I add my negative 4,000 to my positive 5,000, 5,000 plus a negative 4,000 is equal to 1,000 kilogram meters per second. So the system has less momentum than any of the individual carts because it is the total momentum of the system, not just the momentum of an individual piece.